Okay, in the last video we talked about no solution because that was the answer. So a lot of textbooks will use the empty set notation for that. Okay, just so that you know. Some have you type out no solution. Our other textbook has you do that. So, but I think this book would like you to put the empty set symbol. Okay, so now we're going to talk about making a rational equation. And this problem's worded a little bit differently, so I wanted to go over it. But consider the equations. Okay, so they give us this equation, and they give us this equation. This is y sub 1, and this is y sub 2. And it says find all the values for x for which y sub 1 equals y sub 2. So what we're doing is we're taking this 3 over x plus 6 plus 1 over x minus 2. And we're saying that's going to equal y sub 2. 4 over x squared plus 4x minus 12. Okay? So that's all the wording, okay? We kind of had to make our own rational equation. And we're doing that because they said y sub 1 equals y sub 2, and so we set up that equation. Okay, now we're going to have to factor any place that needs factoring. So here we have a denominator of x plus 6, that factor. Here we have a denominator of x minus 2, that factor. And then we're going to have to factor this trinomial. Now, my guess is it's going to factor into x plus 6 times x minus 2. But I don't really know that. I could think, what are two numbers that multiply to be negative 12 and add to be 4? And I would get 6 and negative 2. So, you could do it that way. Or however you factor. Okay. So let me rewrite this. I'm going to have 1 over x plus 6. Which, why did that become a 1? It should be a 3. Oh, I'm sorry about that. 3 plus 1 over x minus 2. Now I'm leaving a little space because I'm going to want to multiply by the LCD. And then I'm going to have 4 over x plus 6 times x minus 2. Oops. All right, what is the LCD? Well, look at all your denominators, and what do you have to have? You have to have an x plus 6, and you have to have an x minus 2. Do you need anything else? No, because you only have one factor of x plus 6 in any denominator, and you only have one factor of x minus 2 in any denominator. So I will multiply by x plus 6 times x minus 2. Squeeze it in there. Okay, now we get to do the canceling. So this is where the denominators, we get to get rid of them. Before I cancel those denominators, I better say what x can't be, right? I always forget this part. So x can't be negative 6, because that would make it 0 in the denominator, and x can't be 2. All right, so this time there are two things that x can't be. All right, let's see what happens. The x plus 6 cancel, and the x minus 2's cancel. X plus 6 cancel, x minus 2's cancel. So what out of that mess, what equation do I get? Well, I have 3 times x minus 2. Now I can write it this way, or I can have the 3 at the back. That doesn't really matter. So I have x plus 6 times 1. There, I put that one at the back. You can distribute from the left or you can distribute from the right. And it equals 4. Okay, now the good news is we don't have any rational expressions. We just have a linear equation that we're trying to solve like normal. So we're going to distribute 3x minus 6 plus x plus 6 equals 4. And I'm going to get, let's see, 3x and x making 4x. And then the negative 6 and the positive 6 cancel out. I'm going to divide both sides by 4. And I get x equals 1. Now, I have to check. Was it one of the values that I couldn't have? No, I couldn't have negative 6 and I couldn't have 2. So x equals 1, that's okay. If you like writing it in set notation, or somebody asks you to write it in set notation, it looks like that. Okay, so there's that problem.